Okay, so welcome again. So let me take a few questions before we start. Yeah, go ahead, Zebing.
Hi, can I share my screen?
Oh, this is a lab-related question?
Actually, I don't need to share it. Why try to git push to the GitHub? It's showing that little write cost and showing that problem related to auto grading.
Problem related to auto grading. So auto grading doesn't. So you mean in the GitHub web page itself, or you mean in
Yes,
the
yes.
terminal? Yeah, in the GitHub web page itself. If
Yes.
you right now don't worry about auto grading at all, as far as you are able to pass all the test cases locally in Eclipse, right? So if the
Yes.
auto grader is failing, don't worry about it, right?
Okay, that's my question.
Yeah,
Thank you.
good. Thanks. So why do we need the get element in Lambda if you are already in the same if you're already in the same class? We usually use the getters because we don't have access to the instance variables, but you should be already in the instance variables, right? No, yes, like I don't remember if I uploaded it, so I'm not sure. Get determined, yes, you can use get determined because you need to check first whether the determinant is 0 or not. Yeah, you can do that. Thanks. And by the way, you have, so if you open the test cases class, the last 3 test cases, I believe, the ones that are testing the efficient solving, you have to add this add test hint to the, let me see. Yeah, you have to add this add test hint, the one that I'm just writing with the chat right now, to like before. So simply every single test case has to have this add test specifier, otherwise it will not run, right? So I have missed 3 of this, like the last 3. So please make sure you add them to make sure they are running, right? Otherwise you won't be able to check your efficient solving. Good. So let me see the other questions here. Well, in the efficient solving Yolanda, you shouldn't be using the full matrix I and J. You should be using the upper triangular matrix, which is the 1D representation, right? So don't go to this direction. You don't need to use try and catch. If S is fine, that's fine. If you want also to use the try and catch as I do in the test cases, just to copy the same logic, that's also fine. It's optional, it's up to you. As far as you are testing correctly, that's all what we need. Good. Okay, so thanks everyone. I guess you should be able to see the slides. Those slides are already uploaded. Today we are discussing one of the interesting topics in object-oriented programming in general, which is inheritance. What do you mean by inheritance? So let's see. So simply, inheritance in Java or in any programming language means that there is a class that takes or inherits or extends an old class. So we have an old class that we're going to give it a name right now. And then there is another class that uses this class as a basis. You can think of this as a parent and child, right? As we will see that terminology right now. So the rule is that the new class inherits all the features, all the instance variables of the old class, including also all the methods of that class. We usually in Java, we call the old class or an OOB in general, the parent class, the base class, or the super class. All the 3 names exist. I mean, you'll find people use these words interchangeably and they mean the same thing. While the new class or the child class, the one that extends the original class, this new class here, we call it a child class, a derived class, or a subclass, right? So what do we really mean by this? What is an old class, new class, parent class, child class? It might seem confusing. So let's go back again to what we want to do, because the most powerful aspect of OOB is that it better represents the real world as we discussed before, right? So let's take an example from the real world. Assume, for example, I have a class, or I would say a category of objects or a group that share similar features, something like mammals, for example, in the real world, where we know that mammals share certain characteristics like warm-blooded, have hair, whatever. But then those mammals are the big category. You can categorize them or classify them also into subgroups. Something like horses, for example. All horses are mammals. So all the horses, they have the characteristics of the mammals, right? While, oh, I'm not sure if it's recording. For some reason, it doesn't show it's recording. Give me a second. I will stop sharing and then reshare again. That's really interesting. Okay, so it's okay. It's recording. Good. Okay, good. So, so we have mammals like the big or the umbrella or the higher group, and then we have subgroups inside them, including horses, for example, which means all horses will be mammals. So we have here mammals. And then we have, under this big group, many subgroups, and one of them is horses. So all the horses are mammals, right? So they inherit all the features of the mammals, like the characteristics or the bigger features, while on the other hand, horses have their own features, right? So in that sense, they also extend the features of the parent class or group, which is mammals, because, for example, horses have 4 legs, while not all mammals have 4 legs, right? So that's one possible feature in horses. And the same thing you can think of humans and others, right? So in taking this, if you think a horse is a mammal, but not any mammal is a horse, right? Or not every mammal is a horse, which means horses are subset of mammals, or the class of horses is a subclass of the class of mammals, right? And that means horses have additional features as well, in addition to the, I would say, the higher level features that all mammals share together. In this case, coming back to object-oriented programming or Java, we will call mammal or mammals the parent class or the superclass, because it's the superset, while we will call horses the subclass or the child class. And the way we would write this is, assume, for example, we already have an implemented class that is called mammals. Then we define the class horse that we can call public class horse extends. Here, this is the key word for inheritance in Java, mammal class. What would this extends or this inheritance imply for horses class? Well, this is what we will discuss right now, right? So the first thing that it means that all the mammal instance fields as well as instance methods are already accessible by the horse class, right? So, for example, if mammals, we know that they are warm-blooded, then horses are warm-blooded, right? So you don't need to redefine this. So it allows code reuse. So talking in a software terminology, inheritance allows you to use classes, all the features and everything else in other classes by default. So you reuse your code, as we will see right now with the example of the point class that we use as our main example throughout the Java subset of the course. Good. The other thing that coming into software, we can also say that any object that is of horse type, so if you instantiate an object of horse, this object, we can say it's also an object of the mammal class, right? Because any horse is simply a mammal, right? Good. So this is already discussed. And the other thing that kind of extends what I just said right now, which is an object of the horse class, is simply also an object of the mammals class, right? So the inheritance, I mean, the way you would say the inheritance relationship, it's a kind of an is-a relationship. What I mean by is-a, for example, a horse is a mammal, right? So any subclass object is an object of the superclass as well. Good. But again, it's not by default that any object of the superclass would be of the subclass. Going to the physical example, not every mammal is a horse, right? So you have, I don't know, whales or humans, then those are not horses, right? One of the main rules that I want to bring in, so if you follow the way that I'm following in Java in general, I'm really trying to focus more on the concept rather than the Java syntax. And when it comes to something that is specific to Java, I mention it very explicitly, right? So one thing here is inheritance in general. Some languages, C++, for example, allows you to have one child class or a subclass that inherits multiple classes, right? So parent 1 and parent 2. This is called multi-inheritance. This is not allowed in Java. In Java, any class can only be a child of a single class, right? But you still can have a chain, which means this parent itself can also be a child of another parent, which is a grandparent in this case, right? So in that sense, the child is a subclass of parent, as also is a subclass of the parent of the parent, right? But you cannot have these multiple relationship on the same level, right? Questions, because I have been talking a lot. Let me make sure we understand these concepts before we start looking into the actual implementation. Does it similar to the relationship between different constructors? So no and how, right? Constructors are methods within the same class. Here we're talking about the class itself, and the class itself inherits by default all the features of another class. We will see right now what does that mean even for constructors. But I guess what you are referring to, if you can call a constructor inside another constructor, that's a completely different story, right? Because it's just simply a method is calling a method. Good. Okay, so to illustrate what we mean by this is, let's take the point class that we all know. If you remember, let me just discard. Oh, why did I stop sharing? Okay, so let me take this point class and jump into online GDB. Where is that? Here. And then I guess I might need to select Java, and let's have here point.java. Okay, so here we have our point class that we have been dealing with. We now know it pretty well. If you remember what we have done before in the class composition lecture, we said a class composition means you can use a class, an object of a class inside another class. And we gave the example of this by defining another class that we called circle. And then let me go here, take a template for the circle class. And then in this circle class, what we have done is we went here and defined, in addition to the radius, if you remember, we defined another instance variable that we called center, and this center was of type point, right? So we said point center, and then this center is representing the x and y. And we call this class composition because you have an object of a class inside another class, right? Well, someone else back then also asked me, what is the difference between this and the inheritance, or if this is inheritance? And I said, no, this is a completely different thing than inheritance. Today we will see why, right? In inheritance, you really don't define objects. You make the class itself extends the parent class. What means, what does it mean? It means that the circle class will be a child of the point class. As we have just discussed right now, theoretically, that means all the member variables of point, which includes the x and y here, will also be inherited, which means they will be part or instance variables of the circle class. Good. So which means you can really access them inside here without needing to call an object or define anything of the point class. By just extending the class, that means this class has all the instance variables and methods of the point class, right? As we will go further right now, right? Good. Questions? Moaz, does the child at the bottom of the chain have all the property of all the parents on the top? Yes, it has all the instance variables and members of all, like the superset of all the parent classes. That's correct, Moaz. Is there a question?
Can you zoom in, please?
Ah, yeah, thank you, Nico. Yeah, sure.
Thank you.
Okay, so now let's see how do we move forward with this inheritance thing. The first thing that you need to do to create a child of a parent class is to use the extends reserved word or keyword. And here, this is the parent class, while the circle is the child class that you are creating, right? Right now, you don't need this anymore because you already have X and Y access to it. So protected, the first thing you find here is this protected reserved word. We never had it before. When we saw it, I told you just leave it for now, right? What we had before is public or private or just nothing, right? Protected is simply very similar to nothing, which means if you don't have anything here, if you remember what we said, is now this variable will be accessible throughout the package or the folder of the project, right? If you add protected, it's exactly the same thing with one additional feature, which is also this variable will be accessible by all the child classes if you create another child of the circle class, right? So protected reserved word means the radius variable here will be accessible by circle class or even the main or any other class that exists in the same package. I guess we don't need this. And then it means also if we create another class of circle, let's say, for example, I don't know, a bank circle or whatever, a special circle, right? Then in this case, a unit circle, for example, then in this case, this unit circle child class will also have access to the radius class. So if you go to the point, you will find that I, for example, defined X and Y as protected right now. That means this circle class will have access to X and Y. Good. Okay, so what else do we find? I go again with my flow of defining a class. I define the instance variables, constructors, and then getters, setters, and then methods. So let's look into the constructor. For the constructor, I just define the constructor regularly. We have done exactly this constructor before, but we didn't have this super, so leave it for now. We use set radius, and if you remember what we have done for class composition is we needed to call the object of center and to say, I guess, center, we needed to say, I guess, center equal new point, and then we sent A and B, right? If you remember. Because now we call the constructor of the point and pass A and B to X and Y, right? Or even we can use set X, set Y for this if we want. Good. Right now, you really have a direct access to X and Y, but the way you do it is you want to call the constructor of the parent class. The rule here for constructors, and that's a very important rule, is the first rule we know, the constructor is the first method that is called by default for any class, correct? Once you create an object of that class, the constructor is being called. What if you don't have any constructor? Do you remember? What if I didn't define any constructor in my class? What would happen? There is a default one you call, that's correct, which is the one that is just simply like an empty constructor, which what will happen is that everything will set to 0 and null. That's correct. Then the only additional rule we add to these, I would say, this set of constructor rules is that if you have a child, if you have an inheritance relationship, a child class, the first line that get executed in the constructor of the child class is calling the constructor of the parent class. So assume, for example, I didn't have this super thing. So what is going to happen is the first line again will also call the constructor of the point class. But which constructor is going to be called? It's the default one, which is the one that takes no input parameters. But if I go here to point, well, I find that I have this, right? This is the one that is going to be called. But if I don't have this, let's do something like this. And then, yeah, and let's try to run this example. But I believe, let me remember if, yeah, let me try to define something here. Like circle, my circle equal new circle, and then I am calling my radius to be, I don't know, like 10 and then 0 and 0, right? So what I'm doing right now is I'm using the circle class in the main, because by the way, the child class is a normal class, which means you can use it exactly the same way you use any class. And then we are calling the constructor that takes 3 input parameters, which is this one, right? RAB. So if we try to run this, we have to get an error. So let's see. Online GDB is sometimes not. Okay, because I copied things from the PowerPoint. So I guess we have to fix few stuff, which is this one. And this one is, oh, come on. Okay, that's all, I guess. Let me see. Circle, yeah. So let's try then. Come on. What do I have here? Ah, okay. Yeah, so if you look into this error, constructor point in class point cannot be applied to given types. What does that mean? First of all, you know that we are getting a compiler error, right? So if you follow what I have just said, the compiler error happens because the child constructor, by default, the first statement that is executed in this child constructor is the constructor of the parent class. If you didn't call any constructor of the parent class, it calls the default one, which is the one that takes no input parameters. But well, we don't have this right now, right? Because we have a single constructor that takes 2 input parameters. In this case, it gives you a constructor compiler error, right? If I uncomment this, then this should work, because as you can see right now, here there is an implicit statement. It's like calling, now I'm going to call it super, but I will explain to you what means super right now. And that's it, which is just for now, know that super is calling the constructor of the parent class or the super class, right? And it's the empty one. So this default one simply is inserted by the compiler if you don't have a call for the parent constructor. So right now, this statement is there even if we didn't write it. And then previously we didn't have this constructor, so you have a constructor mismatch, because you have a constructor that has 2 input parameters, but you are calling a constructor that has no input parameters, right? Then that's a constructor error that we got. If we uncommented this, which is the one that takes no input parameters, and you run, this should work, right? Main method not found in class main because define main. Oh, did I remove the main? What is that? That's really bad. Okay, so circle, my circle equal new circle. Then I'd say 10, 0, 0. Okay. So well, that runs as expected. The reason for this is, going back again, we called an empty constructor, and this empty constructor calls the one that we have, right? So again, the rule is you always call the super or the parent constructor whether you have done it yourself or not, right? So right now, if we want to call a specific constructor of the parent, then we have to explicitly call it. Like This is using the reserved word super. If you remember the reserved word this, which is indicating this current constructor, sorry, this current class, and we can also use it to call the constructor of the current class. Super is referring to our super class or our parent class, right? Questions? Is this referencing the parent directly above the child or the highest parent in the chain of the parents? Oh, that's an excellent question, Karina. We didn't discuss yet. We will see right now what is the order of calling the constructors. So thanks for this question, and I will discuss it for sure. What does that super do? Simply the super do, as I was explaining Yanhao right now, which is calling the constructor of the parent class, right? But now we are calling a specific constructor, which is A and B, right? Like the one that is passing here, this one. Good. What else do we have for the child class? So here I'm setting the radius, but that's a simple thing that we have done before. No problem with this. Getting radius is also setters, getters, that's fine. So let's see if I can write other methods. For example, I would say something like public and then say get X, right? In this case, what if I write return X? Let's see if that works. Sometimes I focus too much on the meaning and I forget the syntax. Well, what does it tell you? It tells you that get X in circle cannot override get X in point. This introduces to us the remaining thing that I want to discuss in this lecture, which is how the method. So what we have said so far is that you inherit as a child. If I jump back here into the slides, let me add an empty slide, or a new slide. Then going full screen. So what we said is we have the parent class right now, which is our point. We derived another child class, which is circle. What we said is that if point has certain instance fields, variables, and methods, the circle will inherit them by default, right? Well, does that mean you have to rewrite them? If you had to rewrite them, that means, well, you didn't inherit them from the first place. There is no point of code reuse right now, right? So trying to rewrite the code of this get X inside circle is like saying I'm going to call this method or redefine the method again as it is, right? So we really don't need to do this right now. Oh, come on. Let me do this. And I didn't delete it because we will need it for another discussion later. But I don't need to do this to come here in the main and say something like my circle. And here is the surprise. Dot get X. And then I would have to take this into an int. I don't know, like A equal this. And then I would, let's print it, system dot out dot print line, and then A equal then plus A, right? So, well, will this work? Now I commented out the implementation of getX, right? So logically, before we know inheritance, this shouldn't work because there is no member variable called getX in my circle. But with inheritance, we know that all the member variables of the parent class are also member variables of the child class. So if you do this, oh, what did I do? Oh, and when you tab, it inserts it from the beginning. Okay. Then if you do this, you find that A is really printing the X, which means the getX works as expected. Again, why that's the case? Because all the methods of the point, which is the parent, are inherited by the method of myCircle, and more importantly, without needing to re-implement them, right? So far, so good? Questions? Maz, why did you set the getX to void if it returns an int? Well, I was just writing anything, so yeah, it doesn't really matter right now. We will see how to change it. So that wasn't the point. So, well, I know that I have this problem. Sometimes I just overlook the syntax because it's not my focus, but we want to get it running. So you are correct. So this should be int. Yeah. Yanha, what does this? Oh, I guess I already answered this. So is there any question with regard to using the methods of the parent without even needing to do anything in the child because you already inherit them, right? If you put getX in your circle class, does it has higher priority? That's exactly the point that we'll go after next. But let me make sure there is no question so far, and then we will come into what if I have then two methods inside, one at the parent, one at the child. First of all, we have already tried the way of having the exact same method, and this failed. It gave us a compiler error. But we will see right now what will happen if simply we change them. So in what cases do you use super? So simply the good behavior, Sandy, is to always use super in your constructor of the child, because by this you have control of what constructor is being called, right? If you don't have super, which is calling the constructor of the parent, then the compiler, as we have said, will call the empty constructor for the parent anyway, right? So make sure you explicitly use, this is a good programming practice, to make sure you always call the constructor of the parent as the first statement in your child, in your constructor of the child class. Good. So now, before going into Yanhao question, which is part of this lecture, in fact, so I hope we understand this thing, right? Where did the pin go? Okay. So we understand that you really take all the methods and the variables by default. One thing just to mention here to show you the effect of protected is even in the main, I really don't need to say .getX. I can simply say .x directly. And this should also work. And the reason for this is X now is a protected variable, which means all the classes on the package have access to it, right? Good. Going back to the slides. We have already seen this. One thing also that you have in the circle class is additional methods, right? Because we said a horse will inherit all the mammal features, but it has its own features and actions, right? So set radius, for example, is a method that only exists in the circle, not in the point class, right? We have discussed the super already. We have discussed the way of using getX and using X directly because it's protected. Well, now we add other methods. That's fine. That's not the problem right now. But here comes one thing that we want to use before discussing the overriding thing. Okay, so here. Assume I want to use, so we said we have access to both the methods and the instance variables, right? And I have shown you that how do you have access to the methods and instance variable by using .x and .getX. Let's see also how to use the variables of the parent class inside the class itself. So assume, for example, I want to write, but let's leave this for now because it will come afterwards. Assume I want to write something like toString, right? In this toString, remember that also toString was a method that exists in point, if you remember, right? So right now, let's fix all of this. Well, that's a lot. Okay, so what do we do here? So if you look into this, I'm constructing a concatenating string together. So center equal, that's a string plus, and then I want to print x and y. Previously, we needed to use get x and get y of the center. So we needed to write center.getx, center.getY, because center was just an object under class composition. Right now, back again, we know that you have direct access to the instance fields of your parent class. You can just write x and y directly, and then just print the radius afterwards, equal radius, right? Can you have one parent with more than one child? Yes, Karina, for sure. And that's the whole point of the parent class, is you really can use it in different childs. And in next lecture, we have a clear example of this. We will create, for example, a package that we will call our graphics package, where we define circles and triangles and squares and whatever, and all will be from the same parent class. Good. Okay, so right now the thing that I was showing you is that we want to use x and y directly inside the child. Well, feel free to do this. So x and y are directly accessible again by the child class. Good. So the toString, similar to the getX, had something that takes us to the topic that we want to discuss, which is in the point. If you go to the point class, I hope I have it here. Inside the point class, you will see that we have a method called toString, right? It's a public string. ToString takes no input parameters. Go to the circle. It's public string, ToString takes no input parameters, right? Exactly the same method, right? Previously, we had a term that we called method overloading, right? If you remember. And what was method overloading? One clear example of the method overloading is here, having two constructors. They have different number of input parameters, right? And this made sense because, well, they have the same name, but they seem to be doing different things. And we said overloading is fine because the compiler will know which one you want to call based on how many input parameters you pass, right? Do you remember that? Right now, that's really not overloading because it has exactly the same number of input parameters. In fact, it has exactly everything, right? So which one wins? That's the main question, right? So Adam, you got confused, and I guess you confused others as well. What is happening right now is the overriding, right? But previously, it was the method overloading because there was no inheritance. So well, let me try to say it again to make sure I remove the confusion. So we have overloading and we have overriding. Until today, we really didn't even hear the word overriding at all, right? It was just overloading, which means a method with different number of input parameters in the same class, and then it's simply just you call whatever you want to call based on how many input parameters you pass. And we call this overloading because you use the same name for different targets, right? This was method overloading. This is the thing that we knew until now, right? What I'm saying is that if you think this is method overloading, then that's not the case, because if you look into point, you have exactly 0 input parameters, and in circle, same name, 0 input parameters. So that's not method overloading, and that's method overriding. So the difference now is in method overriding, it only applies to inheritance, and the method of the child has to be exactly the same as the method of the parent. So they have the same signature, which means same name, same return value, and then same input parameters. Good. That's method overriding. Why it's called overriding? Because as we will see right now, the method that is at the child will override, right? Will basically take priority, as Jan Hao was saying, over the parent one if you use it from the child one, right? While in overloading, well, no one takes priority. It's simply based on which one you call. Is that clear? I hope this clarifies if you have any confusion. So here, it just states what we said exactly. A method overriding an instance method in a subclass has exactly the same signature as the one in the parent class. And signature means the same name and parameter list. And then it overrides the one at the superclass, which means it takes priority over it. For example, here, if I go back to my code and I try to call, so let's first say we don't have this get the toString one. So we didn't implement it yet. So that means if I write in the main something like system, oh, does it print? Oh, just so let me down dot print line, and then I would say circle, my circle dot toString, right? In this case, if I try to run this, my circle. If I try to run this, I get 0 and 0. This 0 and 0, where did it come from? I didn't implement the toString method in the circle yet. It came from the point class, which is the parent class, right? So this one get executed. While if I go to the circle and now implement my method of the circle class, and then, well, I have exactly the same code and run it. If you want to, then it prints what we have in the circle class. This is what is meant by overriding. If you have a method that has exactly the same name and input parameters in the child, it takes priority. If you don't have, then the one at the parent is going to get called. Questions? A signature is the same as prototype. Well, for now, let's say yes. The only difference will be in the return values, but I will discuss the return values afterwards. So there is a special point to make about the return values, right? Nicole, override, do you need it? Well, that's a compiler hint, but you don't need it. You will find in the starter code, for example, we write it, but that's fine. You don't need it. That's the general rule of the language anyway, so you don't need to write override. But if you write it, that's a good programming practice, because some compilers, some IDEs need these hints. Isn't naming something the same as the name bore brackets? Naming something the same name? Oh, Jack, that's an excellent point. So, and I guess this point also applies to method overloading, which is even if you don't have classes or anything, and you have a method that has the same name, and by the way, we have overloading also in C. So, well, is this something bad? It's something bad in general, unless you do it in purpose, right? And one example for this is you might have, for example, constructors is a clear example. You want to initialize using different conditions based on the use case. That's one possible scenario. The other possible scenario is you want a function that do some functionality. For example, here printing something, but this thing will depend on which object you are referring to. So in inheritance, you might have a chain of parents, and then when I want to print, I might want to print the current status of the child or the one at the parent. And in this case, it's good to keep the terminology the same because they do exactly the same functionality, but for different objects, right? So it depends on the use case. Can you call the superclass toString? Mark, this is one reason why I answered Jack the way I answered it, because I said, well, if I want to call the child and the parent, and then, but right now we only can call the child. So what do I need to do to call the parent one, right? That's one thing to discuss right now. We are taking the discussion in a logical way. That's perfect. I like it. So, and I really, the question might be, I would say subdivided into two different questions. The first one is, what if I want to call toString in the main, so in a test, or I want to call toString here inside the class itself, right? Something I can do as a modification is, what if I want to call the toString of the parent inside the child? Can you just guess what can I do? Super, exactly, Aaron. Or Adam, yeah, that's correct. So what I can say is super dot toString, and this should give me X and Y, right? So if I do this, I just replaced, because if you remember super.toString, the point one here, what it does, it only prints X and Y, right? Here. So I replaced the text with this one. And if I run, I should have exactly what I had before, right? Because this is the one that is printed by the super.toString. But you can, so simply for the super, you have to be inside the child class. Now, what if I want to call the toString of the parent inside an outsider class, like the main, for example? What do you think? What should I do? Any idea? Well, simply just define an object. Yeah, Nicole, perfect. So parent class is a normal class, right? What I can do for that is define an instance of this class. So say point, and then my point, and then equal new point, and then I don't know, maybe passing something like 5 and 7, anything. And then here, I can say my point dot toString, and then that's it, right? Oh, I don't print, I only convert to string. So I say system dot out dot print line, then do that. So if I do that, it's simply, if you look here, this has nothing to do with inheritance at all, right? Point is a class. Well, it happens to be a parent of another class, but this doesn't really matter. I can still define objects of that class and use its methods and instance fields exactly as we have done before. And why this is important to discuss, because if we discuss the myPoint class, does myPoint class see or has or have any access to, for example, my circle get radius or my circle toString method? What do you think? Given that this is an object of the parent class? No at all, right? So objects of the parent class don't have any access to the methods or the fields of the child class, right? Just if you get confused, it's exactly the same example we have as mammals and horses. Not all mammals are horses, which means they don't have 4 legs. You don't have access to the specific features of the child, right? Good. So if we run this just for sake of completion, you should get simply like the way that toString is printed in the parent itself, right? Good. Okay, so this is overriding. We have discussed all of this with examples, I believe. Good. So now, I guess we have also discussed the super, and we have discussed how to enforce, like how to call the toString method of the parent inside the child itself. Well, now I guess we also went through this, which is the constructor. The first statement that get executed is the constructor of the parent, and you have this happens implicitly or explicitly by, if you didn't write any call of the constructor of the super, this happens by default, and it's the empty one. Let's take some examples to make sure, because there are so many tricks in this thing. And I guess also there was one question, I don't remember who asked it, but the question was, if you have multiple parents, which one, what is the order that this happens, right? So let's see. So I have here a class A, it's a generic class A1, and then this is the parent, basically. And here we have the child, right? And the child, this is a constructor of the child. If I didn't have anything, well, this shouldn't work. Why this shouldn't work? Because as we said, if you don't call the parent constructor, the empty one gets called, but we don't have an empty one here, so well done. So if you call it yourself and you pass, like basically you are calling this constructor here, then this should work, right? So super 5 and this dot y equal y, and if you print stuff, it should work, right? So let's have another example that clarifies another thing. Right now, I don't have any constructor in the parent, right? So here, there is no constructor. Well, here also, I didn't call any super thing. What I'm writing right now is this gives you no compiler error. I'm just claiming this. So why that's the case? What do you think? Well, that's already written here, which means by default, if you didn't implement any constructor for a class, an empty constructor gets called by default, right? So that means here you have the empty constructor for the A2, right? So basically, if you don't have any constructor, there is the default one, which is A2 and then empty one, right? And we said by default, if you call the super parent constructor, the empty one gets called. So it calls this one, right? So no compiler error will happen, but really you will have a runtime error, because in this case, in this runtime error, so well, let me think. Yeah, I have already initialized X, so I don't need to care. So this should give you X and Y. That's so yeah. If you already initialize X and you give it a value, well, the constructor really does nothing, and you're good to go, right? But then, if you define the empty constructor yourself, and this is the good programming practice, you should have at least one constructor, even if you don't want to do anything, even if you leave it empty, just have your constructor, right? So, and here I didn't call anything. So what is the rule? If you don't call anything in the child constructor, the empty constructor gets called, so this one gets called. And then in this case, well, we don't have any problem. X gets the value of 20, and then, well, at this line, X is 20, but then afterwards you overwrite it by 1, right? And then your Y gets Y, which is what the value that we pass for Y. We don't know which one. Yeah, here I'm passing 10. So you get 1 and 10, right? So also another thing you want to know is the order of the operation. So the first thing you do is calling the parent constructor. Parent constructor is assigning X to 20, but afterwards you overwrite it, right? One thing that might be tricky here is why we didn't say super.x. We just said this.x, because again, child has access to X and Y or any instance variable of the parent. So I don't need to use the super. It gets for me for free, right? Good. So, well, I didn't yet discuss the point of the ordering of multiple inheritance because this will come later, but let me quickly answer the question to make sure I don't leave you with open questions. Assume I have parent 1 that inherits parent 2, and then parent 2 inherits parent 1, and then parent 3 inherits parent 2. And let's say inside this empty constructor, I'm assigning X to 10. Here I'm assigning X to 20 and X to 30, where X is simply just an instance field at parent 1 and X, okay? So what happens? If you follow the rule that I told you before, if you define an object of B3, in the main, for example, you say, okay, like B3, my B3 equal new B3. In this case, the first thing is you call the constructor. The first statement you execute in this constructor is what? Is the parent constructor. Well, the same rule still applies, which is the first line or statement you execute in this constructor is the parent constructor, right? So that means X equal 10 is the first statement that gets executed, then X equal 20, then X equal 30. So the order of execution is like this, which means at the end, if you print X here, you will get 30, right? So the rule is if you have a chain of parents, the very first grand parent is the one constructor that gets executed, and then it follows afterwards. We'll discuss this Vinay. We'll discuss this generally, yes, but we'll have a separate discussion for this about the private variables. But simply, if you want to your childs to access your members, you should have them as protected. Yeah. Sagnan, should we use the instance variables of the superclass in the child constructor, or should we use super in the child constructor? As I said, Sagnan, if you don't use the super, then the super will be called by default, whether you do it or not, right? As we have seen in the example we discussed in online GDB. So then it may be better to just explicitly do it yourself to know exactly what's going to happen. Sandy, the child class can act as a parent class of another. Yeah, right now we have B2 is a child of B1 while its a parent of B3, right? And in fact, it can also be a parent of another class here, B4. You can be a parent of multiple classes. Good. Are there any questions? So let me see if we still have some time. Well, we are over by 3, but we are done for today. But if you got questions, please ask. And hopefully by tomorrow morning, I should have all of this uploaded. Good. A general question: how to choose between composition and inheritance? A circle can also be implemented by composition. Good. That's an excellent question, Guten. So composition has limited capability compared to inheritance, right? So, and the general rule, you should think of the real use case. Is circle really, I would say, a child of point class? Well, in a sense, you can think of this like this way, because a circle is nothing other than a series of points ordered in a certain way, right? But in reality, it might not be very close. A circle might be better a child of another parent class that is, for example, a general 2D graph, right? So because circle is a 2D graphic thing, right? So I would say what determines whether you should have a child of a parent or an inheritance relationship is if really this resembles the real world, right? While composition is just the natural thing. It's like simply defining an object of a class inside another class, which we do all the time. You never write a class and don't use it, right? So composition is just the default thing. You opt for inheritance if you really feel that this parent class has capabilities that you can really drive many out of it. And next lecture, we will see this. We will see, for example, how to create, because shapes, 2D shapes, you can have a general 2D shape class and then do a circle out of it, square, rectangle, triangle, whatever, right? So that's a more realistic example. Moaz, can you quickly explain protected again? So protected has two things. Those protected variables, any class in the package have access to them. The second thing, all the childs have access to them as well. Karina, lab question. Someone was asking about using get element for the last question earlier, and I was wondering what was the answer. So yeah, I guess Yolanda was asking whether get element should be used, and what I said, get element of the matrix, that means you go to the direction that if you're using the full matrix class, but that's not an efficient solution. So you shouldn't follow this direction, right? Because you should use the efficient representation of the upper triangular matrix to get the efficient solution. Sure. Okay, so is there any other question?
Excuse me?
Yeah, go ahead.
I'm just wondering, does the class has something like the recurrence function, I guess? Like, can one parent class also be another child class? 1 second. Like, if I have some class A, can A be the parent of the B, but also be the child of B?
Oh, circular inheritance, you mean? Like if you have A and B, where A is the parent of B, while on the same time B is the parent of A?
Yeah, exactly.
Well, no, right?
No.
Because simply that's not an inheritance relationship, right? Think again of this example of real use case. You go for inheritance when you feel that there is a superset and a subset, right? So it's not possible that the superset will be also a subset of the subset, right? So it's not a two-direction relationship, right?
I see.
Yeah, but the recurrence, on the other hand, is a more of an action, right? So it's something related to the method, not a class, because the recurrence means you need to execute something multiple times. But inheritance is not about execution. It's about inheriting features and methods, right? So you take everything and I can use it, right?
I see.
Yeah. Good. Is there any other questions?
Yes. Can you just wait me for 1 second?
Sure. In the meantime, are there any other questions from someone else?
Hi, can I ask a quick lab question if that's okay?
Sure.
So I was just wondering, for the get determinant method in the upper matrix class, so do we have to implement it using like the 1D efficient array, or can we, for example, like call like a method to create the full matrix and then implement it as a 2D array?
Okay, so I see. So well, the good practice one is to get it from the efficient representation of the triangular matrix. But the answer is, if you are not instructed in the lab document in order not to use this or not to do this way in this specific method, then well, I cannot prevent you from doing that, right? So if you're not asked not to convert it back to the full matrix and then calculate the determinant, then well, you are free to do that if you want, right?
Okay, thank you. So try to do it like using the efficient way, but
Yeah,
if not, then that's okay.
because if you come up, yeah, that's exactly what I want to say. And also, well, assume you use the full matrix representation for this. When you go to the efficient solving one, you will have to come up with exactly the same expression that you would have to come up at the get determinant. So it's like just delaying the problem for another method, right? What I mean is, if you were able to calculate the determinant using the efficient representation of the upper triangular matrix, your solution for the efficient solution, like the last method, will be almost exactly the same thing, because you need to come up with an expression, right? That's the whole point of the last question. So whether you come up with this expression in the efficient solution or in getting the determinant, well, it will be the same effort anyway. But again, going back to the official answer of this question, yes, you can use the full matrix if you are not instructed not to do so in the lab manual. Yeah, for the get determinant method.
Okay, thank you.
Yeah, welcome. Jan, how are you? Yeah, go ahead.
Yeah. Just a couple of quick questions. Like the protect can be accessed by itchild, right?
Correct.
What if the private
no. And
okay.
I guess someone also asked this, and I said I will revisit this, I guess, in subsequent lectures, but no, the general answer is no.
I see.
Also, private cannot be accessed during this, like within the same package, right? So let me remember. So to be honest, I need to double check, but I don't think private are accessible by the child. I don't think so, but I can double check, and then we are discussing this next lecture anyway.
Okay.
Yeah.
And one more thing about the overloading. I know the overloading can use for the constructor, but it can also used to those methods.
Yeah, it can be used for any method. Like it's not, and in the overloading discussion lecture we had, we have done it in two examples, one for the constructor and one for another method. So yeah, for sure, you can do it for.
Okay. And just one more thing to make sure, like we haven't learned how to overriding those signs, right?
Those signs, what do you mean by those signs?
Like remember today's tutorial, there is something like you are looking for some set, you're looking for some element in set A but not in set B.
Okay.
But you use that method by calling a sign. It looks like a divide sign.
Oh, no. This is just how we represent it in math, but this is not how we are going to program it. If you look into the starter code, it's just a normal syntax. So by the way, there is no overriding for operators in Java. This is only done in C++. So we cannot do this in Java. Yeah.
Okay, I see. I have heard that on C++, but
C++ you can do this. Yeah, but Java is not allowed. And well, we're not doing this anyway in the lab. So I guess I was only using this as a math terminology to discuss what we mean by the difference between A and B. But
I see.
The function itself or the method itself is called difference, right? It's not called this slash thing. Or,
Okay.
Yeah.
Thank you.
Yeah, welcome, Yanhao. Are there any other questions? Good. If I implement the get element method in lab 4 using the efficient way, just like expression, can I use it in the last method? But get element getting is a method in the matrix class, if I remember correctly, right? Well, it's a long time since I looked into this lab. So if you remind me, I don't remember, to be honest. Is it like, are you referring to the get element of the upper triangular matrix? So I would say, well, follow the instruction in order not to confuse yourself, which is don't call other methods. I mean, except for get determine if you want. But other than this, just write your own implementation. So Gotong, are you trying to talk because I don't hear you? Okay.
I guess is he asking like, can you use some method from the matrix when you are doing the?
Yeah, this is exactly what I was saying before for Yuland and others. No, don't do that. Don't do that.
Huh? Wait, what?
Don't use the matrix methods when doing the efficient solving method in the upper triangle matrix. It was a clear instruction in the lab manual not to use or not to call other methods for that, right?
But in the upper triangle matrix, you are actually using some feature of the matrix, like
we are
matrix,
only
right?
correct. We are only talking about the efficient solve method, which is the last part, right?
Mm-hmm.
But everything else is fine, right? Am I confusing you more, or so I'm not sure what is the problem then? Okay.
Never mind. I see.
Okay, thanks. Okay, so thanks everyone. I have a question about the previous lab mark and my midterm. When I ask you about those, Grotovo, for the midterm, if you didn't email me already, please email me because I have re-logged into all the ones that they have questions about. For lab, please email Salah, like the master TA. Let me resend the email here in the chat. And you can CC me if you want. Okay. Okay, good.
Could I ask a general question real quick?
Sure.
Yeah, so like I said, like a general question, like for example, with the circle class, like with composition, it's like we would be using a point object in the circle class.
Okay.
Whereas like inheritance, we're making like a subclass of the point class, which like because a circle is just like a series of points, right? So it'd be better to inherit it because it's like it'll have all the properties of the point class, and then you can just like a special type.
Correct. You are correct. Generally, you are correct. Yeah, inheritance is more powerful than just class composition. So yes, you are correct.
Yeah, but like in this case, composition would just be using a point object in the separate class.
Correct. Correct.
Okay, thank you.
Yeah, Moaz. Yeah, that's correct. Okay. Thanks everyone again. I guess Kai, if you want to talk, so if you guys don't have question, can I ask you please to leave because I guess I need to talk to one of you privately. But if you have other questions, please go before you leave.